All right, we want to solve the inequality here using a sign diagram. A calculator would do this quicker. We'll show you at the end how that works. But again, we want to find where on the number line this inequality is true, where it's greater than or equal to 0. So when you see a rational function, the first thing you want to do is you want to factor it. In this case, and like many cases, it factors nice and pretty. We have to define the domain first. The domain of a rational is always all reals, but we can't let the denominator be 0. So x cannot equal this time 1 or 7. That makes the denominator 0. So I'll call those my undefineds. All right? And the other thing we want to identify, because we're trying to find where this is greater than 0 this time, we want to find where it's positive. We want to know where the zeros are. Those are the difference between negative and positive. So I look in the numerator, and I see that the zeros this time, which are not the same as the undefineds, the zeros occur at -1 and +3. And they don't match the vertical asymptotes of the undefineds. Whoops. And we can now make a sign table, and we can use these as our points of interest, okay? Because we know that the undefineds don't have any sign value, and we know -1 and 3 are 0, and they have no sign value. So we typically make a big, ugly table. All right? And we start from the left, and I'll go -1, 1, 3, and 7. -1 and 3 are zeros, and 1 is undefined, and 7 is undefined. I make this box because the 4 lines I just did have no sign value, but we want to know what's going on in between. So we have 4 factors in our red here. We have 4 factors. The question is what sign are each of those factors? So I have x plus 1, x minus 3, x minus 1, x minus 7. All right, and I move this stuff up to give myself a little bit of room. I am looking for when all this junk is greater than or equal to 0. So I call it f of x. And say f of x is going to be greater than or equal to 0. Well, I got 2 places where it's 0, so I know 3 and -1 are part of my answer right now. But now I got to do the signs first. So I'm looking in this interval from -infinity to -1. I pick a big number, -1,000,000. -1,000,000 plus 1 is still negative. -1,000,000 minus 3, negative. -1,000,000 minus 1, negative. -1,000,000 minus 7, negative. When you have the product of 4 negatives, you get a positive. That is going to be in our interval. Again, in between -1 and 1, I think it's 0. Positive, negative, negative, negative. It turns negative. Between 1 and 3, I think of 2. Positive, negative, positive, negative, positive. Because you have 2 negatives, make a positive. Between 3 and 7, I think of 5. It's negative. It's alternating sign. This time it doesn't always. And above 7, positive, 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 positive. So now we know that this relationship right here is a positive relationship. So I have 0 and positive, positive, and 0. Oops, I miscircled that one. 0 and positive, and positive. Now I just have to identify those intervals. If I make a number line, maybe this helps students see it better. -1, 1, 3, 7. I have it equal to 0 at -1, solid dot, going to the left. I have it going from 1 but not equal to 1 to equal 3 where it's 0. And finally I have an open circle and it goes to the left on 7 for x. The interval here then becomes -infinity, including 1 square bracket, and open bracket for the open circle 1 to 3 square bracket, and open bracket 7 to infinity. And this is the solution set. All right. Now, we have a calculator. We just program this in. The initial one, we take a big picture of it. All right. Whoa. And I bring it to front. Hopefully that will. Okay, good. And I bring it to front. Here's what I want you to see. At -1, it's really hard to tell. Oh, this is -1. I miswrote this here. This is -1. At -1 on, it is above the axis. So that is this interval. From 1 to 3, here's 1 to 3 right there. All right, to 0. That's above the axis. 7 to infinity. Here's 7, the asymptote, above the axis. Again, all positive results. So if you graph it, you can just look at it. But we don't graph it. We make a sign box. All right. We can use our calculator if we want to check it. But again, a sine table is this, and we've just determined the interval for this. We just solved this inequality. We found its interval.